We're going to take a look at just a couple of foundational pieces when it comes to solving for x, and then just decoding crazy word problems and some weird scenarios that can be presented to you where solving for a is a little funny. I wanted to start with reviewing the concept there of solving for the actual value of x on something like this here, where there's two different methods, and I'm going to show you both right now. So I'm going to just change this question real quick just to make this a little bit more challenging, interesting, / valuable. I'm going to make that an equal to right there when you try and go through this one. There's a reason behind that, and that when we think about these functions going like this, sinusoidal functions, okay? If our objective is to find x values, you'll notice that there's many of them, right, in that case. But what we are doing is we're defining a sort of range, or in this case, a domain, to actually look at for where do these x values actually exist. Now, first things first, whenever you solve for x, you're going to get two values. And if like this is my h and k right there, and I were to go solve for the first 0, I would find this one, and I would find that one. If I wanted to find the rest of these guys as well, what I need to know is that there's a relationship with these first ones here. I'm just trying to highlight this there. This one and this one are a period length apart from each other. Alternately, this one and this one are a period length apart from each other. And the same thing goes with these two and with these two here. So one's on the up, one's on the down, and you can kind of replicate that. So before you start anything, so on this guy here, we're going to try and figure out what the actual period is before we do anything else. You can do it later at the end. You can kind of do it once you find your x values, but just show it right off the get-go. Useful for me. I can find out period because it's 2 pi divided by pi over 8. Again, this is just like a fraction game here. 2 pi divided by pi over 8, you should know right now, is just multiplied by its reciprocal, right? Pi's cancel each other out. That's going to leave me with 16 as the period. So the cycle repeats every 16 units. Okay. That's going to be important later on. Now, this is the function that we're working with. We're asked to find the actual zeros of this guy here. So what are the zeros? If not, 0 is equal to -2 sine pi over 8 x plus 2 square root of 2. What I mean by this is I'm looking for x when y is 0. I'm looking for those first two x's, and then I'll add the period to it, each of them, and then see, does it fall in that window? I mean, that's a better phrase, window of 0 and 16. I just don't like using range because of the connotation it has with y values. On this guy here, our objective, and I want you to know this, that this sine b, x, and h, right? That is a unit that we're going to try and isolate for. So if I don't know x, I want to isolate for that sort of segment, meaning I have to get rid of both k and the a. So I'd bring him over, -2 sine pi over 8 x plus 2, and I would then divide by -2. That step is going to be the same for both. So I'm only going to show it once. So that's going to just be positive square root of 2 over 2. We're going to leave it as the radical right now, sine pi over 8 x plus 2. So this is where it's going to split off. Now, the first version, and this is kind of what your calculator is doing, and there's some common ones. That's what this unit circle is showing you, is just common values for finding out what the square root of 2 over 2 can actually turn into and be useful in terms of solving for x. So at this stage, we are now going to look for like sine, any sine values that are positive square root of 2 over 2. So let's look through here. I found 1. I found 2. Meaning that angle, or the two angles that we just found, are right there and right there. So they're in quadrant 1 and quadrant 2. So for now, there's a lot on this unit circle. All I care about is the fact that it said sine square root of 2 over 2. I'm not looking for cosine. We're not dealing with the cosine function. But when we do, this same procedure will work for that. For right now, we're just looking at sine. And the angle that we will return in radians is going to be pi over 4 and 3 pi over 4. So I've got pi over 4 for this angle and 3 pi over 4 for that angle. So for the unit circle version of this, it essentially is just us looking for all the sine values of square root of 2 over 2 on the unit circle. So anything that was labeled as such. And from there, we can now write it out and split it off. So one answer is pi over 4 is equal to pi over 8, x plus 2. And the other one is 3 pi over 4 is equal to pi over 8. Which is on the side, x plus 2. So you'll notice now, where did the sine go? Well, that was me using the unit circle. I was basically taking a coordinate point to try and figure out what the angle was in radian form. So that coordinate set using the unit circle there. So then now we can just divide by pi over 8, cancels it, divide by pi over 8. Same thing over here, right? Those guys cancel each other out. Really, this just becomes 8 over pi times pi over 4, right? So if you want to just calculate this here on the side, 8 over pi times pi over 4. Pi's cancel each other out. That just becomes 2. And then over here, it's just going to become, right, 8 over pi times 3 pi over 4. So the pi's cancel each other out. 24 divided by 4 is 6. So now I have 2 is equal to x plus 2. 6 is equal to x plus 2. Bring that over. X is equal to 0. X is equal to 4. So we're not done yet. Recall that the period matters. So what we are going to do in this instance is go 0 plus 16 and get 16. We're also going to do 4 plus 16 and get 20. Now, in terms of the values I've already found for x, we found that x can be, in this case, 0, 4, 16, and 20. Now, the original range or window we were looking for was this right here. And I wrote in the including 16, meaning he works, but that one would not as a value for the window I'm looking in. So 0, 4, and 16 would essentially be the potential answers for this guy. Now you'll notice here, like if you use the unit circle, the math, there's like a little section here that the unit circle does the work for you. When you go to the calculator, there's some like extra work that needs to be done. So let's start at the same place that we were at. So we were at square root of 2 over 2 is equal to sine pi over 8 x plus 2. So we were still here, but if it wasn't something nice in a radical form that existed on the unit circle, and I then wanted to see what this guy is with decimals. So let's write it out. 0.707 is equal to sine pi over 8 x plus 2. In this instance, right, we're trying to figure out how we can get rid of sine, and do something with that 0.707 to get the radian angle measurement. So you may even recall, like from last year, this is just as an aside, when I had sine theta is equal to 0.707 as a value, like I did opposite over hypotenuse and had a value and was looking for theta, I would go sine -1 of 0.707 and get a degree value in return. This is essentially what we're doing, right? We have sine on one side of the equation and 0.707 on the other side, and I'm just actually pull this guy up here again. Sine theta was equal to a portion or ratio, if you will. Let's call it that. Theta, I didn't really go over this in class, is equal to the combo of b times x minus h. So let that sink in for a second, that this is the equivalent of theta. That's why this whole situation kind of works for us. It's returning as something useful. And we're trying to find out, in this case, what an x is, using that same sort of like logic that we use with triangles. So that's just an aside. You don't necessarily know that. That's just kind of more of a foundational thing. But from here, and this is how I write it out, and you can kind of do it different if you want, I'm going to write out sine -1 of 0.707. Because at this stage, I've isolated for sine b x h. So now I'm going to plug that in. So making sure my calculator is in radians, just double checked it. Right? And my calculator returned something like 0.785. And so technically, we just found like an angle measurement to go throw into our fake unit circle. And essentially what's going to happen here is, I'm just going to do a different color here. Right? Now, we are going to figure out which one of the quadrants this guy is going to exist in. Now, this returned a positive value. And the cast system essentially tells me that in this quadrant at the bottom here, this is where cosine is positive. Let's use a different color here. This is where cosine is positive and sine is negative. This is where cosine is positive and sine is positive. This is where cosine is negative and sine is positive. And this is where cosine is negative and sine is negative. So we're dealing with a sine function, and we were returned a value of positive, or a positive value, meaning one angle's in this quadrant, one angle's in this quadrant. Now, just like with degrees, we measure like from the x-axis. We measure solidly in that direction, as in there's two angles, right? We know that there's two answers here. So I can't just go find it on a unit circle. I got to use my calculator, and then we're looking for that angle right there. And we're also looking for this angle right here. But the only thing we know about it is that it is theta away from the x-axis. So let's add on to this for a second. In fact, I'm going to do this just down here as an example, just to kind of further elaborate on this. In this case, we're up in these two quadrants, okay? And it could have been in these two quadrants, depending upon whether or not it was positive or negative. And I want you to add this in because essentially all that matters here, right, is we know that it's going to be theta units away from that guy, theta units away from the x-axis. So if we look around here, and I'm looking in this first quadrant, well, that's basically just zero, starting at zero. So this guy is just theta. So whatever you got, the 0.785, that's basically what it's going to be. That's the angle that it's going to be. But over here, this is pi. When I go from, like in terms of the degrees, what will be equivalent to 180 in radians is now pi. So if I want to figure out what that angle is, I'm going to go pi minus theta. On this one, however, in the third quadrant, I'm going to go pi plus theta. Because again, I'm measuring from that x-axis. And the last option here going the full way around, right? We did first angle, that's 1, that's 2, right? That would be the third one. And then last but not least, all the way around, that fourth angle we can find by doing 2 pi minus theta. Okay, so I'll get rid of these arrows there for a second, just because I feel like that adds a little bit too much to it. But this is all you need to know. Whenever you draw the arrows, I'm either going to be doing just leaving it alone, pi minus theta, pi plus theta, or 2 pi minus theta, depending upon what quadrant it ends up landing in. So let's come back here. I know the first one is in this quadrant, so this guy is just going to be theta. But this one is going to be pi minus theta. So let's actually now just write that out. That's what happens next. We can kind of split this off. Okay? Have one here and then one here. So the first one, let's do the easy one. 0.785 is equal to, now the sign has disappeared, pi over 8, x plus 2. But the other answer is going to be pi minus 0.785 is equal to pi over 8, x plus 2. Now, my suggestion to you at this point is to keep everything to at least 3 decimal places. And I'm just going to rewrite these guys here. 0.785 is equal to, right, pi divided by 8 is going to give me something like 0.0. Let's draw this again better. 5 is equal to 0.393 x plus 2. And on this side, 3.1415 minus 0.785 gives me something along the lines of 2.357 is equal to 0.393 x plus 2. Let me just double check again. Was it x plus 2 or is it x minus 2? It is x plus 2. Oof, I always get worried about things like that. So now we're just using decimals to go ahead and solve. And what you'll notice when I divide here, right? The 0.785 divided by 0.393 gives me something like 1.9975. So I'm just going to say 2 because that makes sense, x plus 2. And then over here, the 2.357 divided by 0.393 is going to give me something along the lines of 6 is equal to x plus 2. So it was like 5.9974 but again, we'll round that because we know we're not taking the full string of values, we're just taking 3 decimals. So now it works out to be the same, right? X is equal to 0, x is equal to 4. So for both of them, it worked out to be the same as the one previous. And you would still now add that additional logic of x is equal to 0 and 4. I'll add the 16 to both to then solve for it that way. But that in a nutshell, you're going to have to find which way works best for you. If you want to learn the unit circle, you'll also have to learn this secondary one with a calculator. So if you want to just learn one, then the second one I showed you is the one that is more transferable across any situation. So we shall leave it at that. Feel free to ask me any questions.